Welcome back, everyone. Let's jump right into the ultimate rulebook for checking the systems that check our air. Today, we're looking at the EPA's Performance Specification 3. If you're dealing with environmental compliance, engineering, or if you're just into the nitty-gritty of how we measure industrial emissions, you know this is an absolute cornerstone document. We're going to decode the exact standards and procedures that make sure our monitoring tech is actually telling us the truth.
Okay, let's dive into this by nailing down what exactly we're evaluating. We're talking about CEMS, Continuous Emission Monitoring Systems. These are those massive, complex networks of hardware and software permanently bolted onto stationary sources, like power plants or large factories, to constantly monitor specific exhaust gases. The stakes here are absolutely huge. I mean, if a CEMS is miscalibrated, our whole understanding of a facility's emissions is basically garbage.
So, here's our roadmap for this explainer. 1. Scope of the specification. 2. Relying on the predecessor. 3. The math and methodology. And 4. Passing the performance test.
All right, part 1, scope of the specification. Let's look at what PS3 actually covers.
The absolute most crucial point here is understanding the timeline. When does PS3 actually apply? Well, it's specifically designed to evaluate the acceptability of the CEMS right at the time of installation or, very shortly after. Think of it as the initial driving test for the equipment. What PS3 does not do is evaluate that long-term performance. It doesn't give you a schedule for daily calibrations or routine maintenance. That long-term stuff, that is 100% on the source owner or operator. So just remember, this is a snapshot in time, an initial installation check, definitely not a lifelong maintenance pass.
And what exactly are we measuring? PS3 is highly targeted. It strictly applies to just 2 analytes: carbon dioxide, which carries the chemical abstract number 124-38-9, and oxygen, CAS number 7782-44-7. If you're out there monitoring sulfur dioxide or NOx, you are literally looking at the wrong document. Those belong to PS2. PS3 is all about the CO2 and O2. Moving right along to Section 2, relying on the predecessor. Let's look at the PS2 foundation.
So the EPA didn't reinvent the wheel here. They heavily leveraged Performance Specification 2 to form the foundation of PS3. In fact, a ton of stuff carries over directly. The definitions, the precise rules for where you can physically install the monitors, the core calculations, references, and even the base equipment specs. They are completely identical to PS2. They literally just lifted those rules straight from the SO2 and NOx playbooks and applied them directly to O2 and CO2. Because it borrows so heavily from that predecessor, the actual performance evaluation really just boils down to 2 core tests. First up is the relative accuracy test, or RA. And the second is the Calibration Drift test, or CD. Pass these 2, and your initial installation is golden. Now, we're about to dive deep into the math and methodology of exactly how those 2 tests are conducted. But real quick, if you're enjoying this breakdown and want to master more of these dense environmental regulations, hit that subscribe button. It really helps us keep bringing you these focused, no-nonsense explainers.
All right, Section 3, the math and methodology. Let's calculate some accuracy. To prove your CEMS is accurate, you obviously have to compare it to a known, trusted standard, right? So the testing methodology requires a reference method, or RM. For oxygen and carbon dioxide, the absolute gold standard RM is EPA Method 3B. The strategy here is straightforward but super rigorous. You collect samples using Method 3B concurrently with the CEMS data collection. Basically, you're pulling the data at the exact same time so you can perfectly correlate and compare those 2 sets of numbers. And this brilliantly illustrates exactly how we do that. This is equation 3-1 pulled straight from the source text, and it's your primary formula for calculating relative accuracy. Now, I know it might look a little intimidating at first glance with the absolute value bars and all those variables, but fundamentally, it's just comparing the difference between our trusted standard method and our brand new monitor. Let's break those variables down to make the math a bit more approachable. On the top half, that D with the little bar over it, that's the absolute value of the mean of the differences. Next to it, CC is the absolute value of the confidence coefficient. Now, remember how we said PS3 relies on its predecessor? Well, you actually calculate D and CC using equations straight out of Performance Specification 2. Once you've got those figured out, you add them together and divide by RM, which is just the average value from your trusted reference method. Multiply the whole thing by 100 and boom, you've got your relative accuracy percentage. But wait, the EPA actually gives us a much simpler alternative calculation, known as equation 3-2. Instead of messing around with confidence coefficients, this equation just takes the absolute value of the average reference method minus the average CEMS value. Super straightforward. It's just the strict difference between the two averages. And as we're going to see in just a second, you can actually use this simpler equation to pass the test under some very specific conditions. Which brings us to Section 4, passing the performance test. Let's look at the final grades.
All right, here's the first hard number you absolutely need to memorize, 0.5. To pass the calibration drift test, your CEMS calibration cannot drift by more than 0.5% O2 or CO2 from the reference value. We're talking about the gas cell, or the optical filter. It has to stay incredibly stable. A drift of 0.6%? No way, you fail.
And here's the second hard number, 20.0. When you're running that big, complex equation, 3-1 we just looked at, the relative accuracy of the CEMS must be no greater than 20.0% of the mean value of the reference method data. That's your allowable margin of error when you're mapping the new equipment back to the gold standard.
Now, what's really interesting here is the alternative pass condition. Remember that simpler equation 3-2, the strict difference between the two averages? Well, the EPA says your results are completely acceptable if the output of equation 3-2 is less than or equal to 1% O2 or CO2. So if your monitor's average is within a flat 1% of the reference method's average, you get to bypass that whole complex relative accuracy threshold and pass the specification outright. A real game changer if you qualify.
Once you hit those numbers, your CEMS installation is officially certified under Performance Specification 3. But I want to leave you with a thought that kind of ties this all back to our chat about the scope. You see, PS3 rigorously ensures that these vital monitors are working perfectly on day 1. But who's making sure they still work accurately on day 1000? That endless pursuit of compliance, the daily maintenance, the constant calibration, all of that ultimately falls right back onto the facility operator. The specification might get you through the starting gate, but the marathon of environmental monitoring, that's just beginning. Thanks so much for joining me for this explainer, and I'll see you next time.